Fear, while unpleasant, is essential for survival. It's a primal instinct deeply embedded in our biology. Imagine our ancestors on the African savanna. They encountered predators, rival tribes, and natural hazards. Fear acted as an alarm system, triggering a cascade of physiological changes that helped them survive. Those who lacked this fear response were less likely to escape danger, reproduce, and pass on their genes. We are the descendants of the fearful, hardwired to react to threats. This fight-or-flight response is still very much a part of us. It's a rapid-fire sequence of events orchestrated by the brain. When we perceive a threat, our senses go on high alert. The heart pumps faster, blood pressure rises, and muscles tense, preparing us to either confront the danger or flee to safety. This response is not always rational or helpful in modern life, but it's a testament to our evolutionary past. Our ancestors' survival depended on their ability to quickly and effectively respond to danger. Those who hesitated, who took time to analyze the situation, were less likely to survive encounters with predators or natural disasters. This is why fear often feels so immediate and overwhelming. It's designed to bypass rational thought and trigger immediate action. In this way, fear has served as a crucial evolutionary advantage, ensuring the survival of our species. Fear is not a single emotion. It's a complex interplay of brain regions, neurochemicals, and physiological changes. At the heart of this response is the amygdala, a small almond-shaped structure deep within the brain. The amygdala is our threat detector, constantly scanning incoming sensory information for signs of danger. When it detects a potential threat, it springs into action. First, sensory information about the threat, such as the sight of a snarling dog or the sound of a gunshot, travels to the thalamus. The thalamus acts as a relay station, routing the information to other parts of the brain for processing. From the thalamus, the information is sent to the amygdala, which rapidly assesses the threat level. If the amygdala deems the threat significant, it signals the hypothalamus, the body's command center, for stress responses. The hypothalamus then activates two key systems: the sympathetic nervous system and the endocrine system. The sympathetic nervous system triggers the immediate fight-or-flight response, releasing adrenaline and noradrenaline, which increases heart rate, blood pressure, and respiration. Meanwhile, the endocrine system releases stress hormones like cortisol, preparing the body for prolonged action. This complex interplay of brain regions and neurochemicals allows us to react quickly and effectively to perceived threats. The amygdala is not only involved in the immediate experience of fear, it also plays a crucial role in learning and memory, particularly when it comes to fear-related experiences. This process, known as fear conditioning, is how we learn to avoid danger in the future. When we encounter a threat, the amygdala creates a strong association between the threat and the context in which it occurred. This association allows us to recognize and respond to similar threats more quickly and efficiently in the future. Imagine, for instance, you are walking down a dark street and hear footsteps behind you. Your heart starts to race and you feel a surge of adrenaline. This is your amygdala kicking into gear. Now, let's say that nothing happens. You reach your destination safely, but the next time you find yourself walking down a dark street, your amygdala will remember that initial fear response. You'll be more alert, more aware of your surroundings. This fear conditioning can be incredibly helpful. It's how we learn to avoid touching a hot stove again after being burned, or to be cautious around certain animals after a negative encounter. However, the amygdala isn't always accurate in its assessments. It can sometimes misinterpret neutral stimuli as threatening, leading to irrational fears and phobias. Understanding how fear conditioning works can help us address and overcome these irrational fears. Why do some people enjoy being scared in controlled environments like haunted houses or horror movies? It seems counterintuitive. Why would we willingly subject ourselves to something that triggers such an unpleasant response? The answer lies in the complex interplay of biology, psychology, and social dynamics. One theory is that the adrenaline rush associated with fear can be exhilarating. When we're afraid, our bodies release a cocktail of hormones, including dopamine and endorphins, which can produce feelings of euphoria and pleasure. This physiological response may explain why some people enjoy roller coasters, skydiving, and other activities that induce a fear response. In a safe environment, where we know the threat is not real, we can enjoy the thrill of the experience without any real danger. Furthermore, engaging with fear in a controlled setting allows us to confront our fears and test our limits in a safe space. We can experience the physiological and emotional sensations of fear without any real-world consequences. This sense of control can be empowering and even therapeutic. It allows us to face our fears head-on and realize that we are more resilient than we thought. In a way, it's like a dress rehearsal for real-life, fear-inducing situations, preparing us to better cope with challenges and adversity. If you enjoyed this exploration into the science of scare, don't forget to like, share, comment, and subscribe for more thrilling content.